Good morning, students, and welcome back. Hope you all are fine and safe. Today we will be learning Science 2, lesson number 5 towards green energy. In this lesson, we will study use of various energy sources, generation of electric energy, process of generation of electricity and environment. Make a list of work that we do in our day-to-day life using energy. Which forms of energy do we use to do this work? Answer is play games, cook food, do cleaning, etc. We use different forms of energy for this work like heat energy to cook food, sound energy to listen music, chemical and mechanical energy for riding, etc. Organisms use energy to survive, grow, respond to stimuli, reproduce, and for every type of biological processes. So, student, let us see energy and use of energy. Energy is a very basic primary need for various types of work. Energy is needed in different forms like mechanical energy, chemical energy, light energy, or heat energy are such forms of energy which we use to fulfill our requirements. So, students, what is energy? Energy is the ability to do work. What are different types of energy? The different types of energy are electric, heat, light, solar, wind, chemical, nuclear, thermal, etc. Now, a very important term related to energy is, the law of conservation of energy. Energy cannot be created nor be destroyed. It can only converted from one form to another. For example, when a candle is burned, wax is chemical energy which is converted into heat and light energy. Second, when a bulb is connected to the battery, the chemical energy of the battery is converted into light energy. Energy can be converted from one form to another by transformation. This fact is used by man to satisfy his needs. In this lesson, we will study about various sources of energy that are now used for generation of electrical energy. The method that are used for this, the scientific principles that are used, their advantages and disadvantages of these method, and also what is meant by green energy. Here is a simple question for you. How many people does it take to turn on a light bulb? It is so simple. Just walk into a dark room, turn on the switch, and immediately you can see the light. To understand energy, first we need to understand the sources nature provides. The natural sources we use to generate power from natural gas, coal, ocean tides, mountain winds. The energy used to create electricity will be first mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuel like coal, fuels, etc. But others are unlimited like solar or wind power. Where do we use electrical energy in our day-to-day life? We use electrical energy in various appliances such as bulbs and tube lights, fans, iron, refrigerator, water pumps, cell phone chargers, television sets, tape recorders, computers, etc. How electric energy is produced? Electric energy is produced in the generators by using the principle of electromagnetic induction. The magnetic field around the conducting wires is changed, and this creates the potential difference. This results in formation of electric energy. Now let us study generation of electrical energy. Michael Faraday invented the principle of electromagnetic induction. This principle is largely used in generation of electricity. This principle is as follows. A potential difference is generated across the conductor whenever magnetic field around the conductor changes. In two ways, the field around a conductor is changed. First one, by keeping the conductor stationary and rotating the magnet. Second one, keeping the magnet stationary and changing the field around the conductor. In both the cases, there is creation of potential differences across the conductor. The electrical generator are based on this principle. They generate the electrical power. We get electricity by changing other forms of energy. For example, we can burn coal or some other fuels which changes chemical energy into thermal or heat energy. The heat energy will cause water to heat and move in a tank. Energy of motion is kinetic energy. The kinetic energy in the water causes a turbine to turn a generator. A generator changes kinetic energy with a spin wire or a coiled wire to electrical energy. The wire is surrounded on both the sides by a strong magnet. On one side, the negative side is facing the wire. On the other side, the positive side is facing the wire. Electrons within the wire are attracted to the north pole of the magnet and will repel or push away from the south part of the magnet. By spinning the wire, it continuously passes by the two opposite charges of magnetism. The electrons within the wire move towards the positive magnetic end and away from the negative magnetic end. This continue a moving back and front, and there is electricity produced. This formation of electricity can also be represented by a flow chart showing generation of electrical energy. There are different types of power generating station depending upon the types of energy sources that is used to rotate the turbine, like thermal energy based electric power station, power plant based on nuclear energy, power plant based on energy of natural gas, hydroelectric energy, energy generation using wind energy, electrical energy generation using solar energy, etc. Now let's first see how thermal power plant works. The thermal power plant converts chemical energy stored in fossil fuel into electrical energy that can be used in our homes and business houses. Let's try to understand the process of energy conversion. First, the coal is ground to finite powder to burn faster, produces more heat. After grinding, heat is passed through the coal to remove moisture from air. This powder coal then bloom into the boiler where it burns, converting chemical energy into heat energy. This burning of coal produces ash and exhaust gases. The ash fall into the bottom of the boiler and thus removed by the ash outlet system. Collected ash then usually sold to the building industries where it is used as an ingredient in various building materials like concrete, etc. The high temperature of water converts the water present in the tube into steam. The hot steam expands in the pipes, which further leads to high pressure. This high pressure steam is then used to rotate the turbine, converting the heat energy generated in the boiler into mechanical energy. A shaft connected the steam turbine to the generator. This shaft transfers the turbine motion to the generator. The generator uses an electromagnet to convert this mechanical energy into electrical energy. After passing to the turbines, the steam comes in contact with cold water pipes. These cold pipes cool the steam so that it can condenses back into water, which is then moved back to the boiler where it can be used again. In coastal station, this cold water is pumped straight from the sea. Finally, a transformer converts the electrical energy at a low voltage from the generator to high voltage. The national grid used this high voltage to transmit this electricity efficiently through the power lines to different power stations, which further transmits to our homes and business houses. Although thermal power generation is a major way of electricity generation, today it suffers from certain problems. They are as follows: air pollution due to burning of coal. Burning of coal results in emission of gases like carbon dioxide, sulfur dioxide, and nitrogen oxide, which are harmful to health. Along with the emission of gases due to burning of coal, soot particles are also released into the environment. This may cause serious health problems related to respiratory system. The reserves of fuels used in this method, that is coal, are limited. Therefore in future there will be limitation on the availability of the coal. Now let us see power plant based on nuclear energy with schematic block diagram. What is nuclear power plant, or what is the basic of nuclear power plant? The basic of nuclear power plant is same as thermal power plant where we use coal as a fuel. So in thermal power plant and steam power plant, when we used coal as a fuel, then we have to burn the coal and then heat is generated, and then that heat is used to convert water into steam. As coal combustion takes place, we have studied there are so many disadvantages like it pollutes atmosphere, it produces ash, it produces toxic gases, and that's why instead of generating the heat by coal combustion, we can generate the heat by using the process nuclear fission. So what is nuclear fission? During the nuclear fission, huge amount of heat can be generated so that heat can be used to raise the temperature of water, and then water can be converted into steam. So this is the basic of nuclear power plant. What exactly happens during nuclear fission? Nuclear fission is the process of splitting of uranium atom. Splitting of atom is called nuclear fission. Here, nuclear material uranium 235 is bombarded with the neutrons. So, when uranium 235 is bombarded with the neutron, uranium 235 atoms get split, and during this process, again the neutrons are liberated. Uranium 235 absorbs the neutron and converts into its isotope uranium 236. Uranium 236, being extremely unstable, converts into atom of barium and krypton through a process of fission, releasing 3 neutrons and 200 megavolt energy. The 3 neutrons generated in this process cause fission or 3 other uranium 235 atom releasing more energy. The neutrons released in this reaction releases more energy through fission or more uranium nuclei. This process of fission of uranium 235 atom continues and is called the chain reaction. What is the advantage of nuclear power plant? 1 kg of uranium produces as much heat as produced by 4,500 tons of high graded coal. So, only 1 kg of uranium is enough to produce the heat as heat produced by 4,500 tons of coal. So, that's why transportation cost reduces and many other advantages are there of nuclear power plant over conventional coal power plant. What is the block diagram of nuclear power plant? We can see different components of nuclear power plant. The main component is here nuclear reactor. Nuclear reactor is a device in which the process of nuclear fission takes place. The uranium 235 are subjected to nuclear fission in the nuclear reactor and huge amount of heat getting liberated. Now this heat goes to heat exchanger. For that purpose, coolant is used. So coolant can be of gas, liquid type. So coolant transfer the heat from nuclear reactor to heat exchanger, and in the heat exchanger that heat is getting transferred to the water, and when the heat gets transferred to the water temperature increases and water gets converted into steam, and then that steam is converted into high pressure steam, and that high pressure steams then rotates the steam turbine. Now the turbine is coupled with the alternator. As the steam turbine rotates, alternator also rotates, and this alternator converts mechanical energy to electrical energy. So the electrical energy can be given to the grid. So this is use of nuclear reactor. So after rotating the steam turbine, the steam goes to the condenser where it again converted into water and sent back to the heat exchanger. So this is basic component of nuclear power plant. Now during nuclear fission process, many radioactive material get evolved. So we have to save the life from this radioactive material, and that's why the strong control system has to be implemented in the process of nuclear fission. So we are controlling the nuclear fission process by using the control rods. Control rods are made up of cadmium. The property of cadmium is that cadmium is good conductor, neutron absorber. So when huge amount of heat is liberated, The control rods are cooled inside the nuclear reactor and cadmium rod absorb the neutrons, so very few neutrons are available for the nuclear fission. The chain reaction can be controlled by using control rods made up of cadmium. This is the control system used for nuclear reactor, which is very important. Now let's see the block diagram of nuclear power plant. Nuclear reactor is there. After nuclear reactor there is heat exchanger. From heat exchanger there is steam turbine. Steam turbine is coupled with alternator, so there is a shaft. From steam turbine there is a condenser. In condenser steams convert into water and again it is sent to the heat exchanger through feed pump and it has a cooling tower. It is the simple block diagram of nuclear power plant. However, there are few problems associated with nuclear power generation. They are: the products after fission of nuclear fuel are also radioactive and emit harmful radiation. The products are called as nuclear waste. However, to dispose the nuclear waste safely is a big challenge before the scientist. An accident in nuclear power plant can be very fatal. This is because the accident may result in release of very harmful radiations. Student, always remember, in nuclear power plant atoms like uranium or plutonium is used to generate the heat. I hope you all understood how electricity is generated in thermal and nuclear power plant. Student, homework for today is: learn and keep question number 2. Which fuel is used in thermal power plant? What are the problems associated with this type of power generation? Thank you. Stay home, stay safe.